Okay, 2 cubed, 2 to the third power is 8. So the cube root of 8 is 2. 3 to the fourth power is 81, so the fourth root of 81 is 3. And look at some of these with x's. X to the third power is x to the third power. So the cube root of x to the third power would just be x. If you start with x squared and raise that to the third power, you get x to the sixth. So the cube root of x to the sixth is x squared. If you start with x to the 3 and raise it to the third power, you get x to the ninth. So the cube root of x to the ninth is x to the third. The cube root of x to the 12th is x to the fourth. The fourth root, well, x to the 10th to the fourth is x to the 40th. So the fourth root of x to the 10th, x to the 40th is x to the 10th. If you start with x squared and raise it to the sixth power, you get x to the 12th. So the sixth root of x to the 12th is x squared. Now notice the pattern going on here. In an expression like the cube root of x to the 12th is x to the fourth, or the fourth root of x to the 40th power is x to the 10th, or the sixth root of x to the 12th is x to the second. Do you see what's going on? When you take this power and divide by the index of the radical, you get the power on the result. Like this is x to the 12 divided by 3 power. This is x to the 40 divided by 4 power. This is x to the 12 divided by 6 power. So what's the cube root or third root of y to the third power? Answer, y. Because the cube root undoes what the cubing here does. If you start with y, raise it to the third power, then take the third root that undoes what the power does and get you back with the y that you started with. The third root or cube root of w to the 30th power, remember that pattern we were just looking at? What do we get? We get w to the 10th power. The ninth root of x to the ninth power would be, well, it would be x to the first power, which would just be x. The fifth root of x to the 35 power is x to the 7 power. Notice 35 divided by 5 is 7. Now, the product rule for radicals says that if you take the square root of two things multiplied together, that's equivalent to the square roots of the two things multiplied together. Square root of a times b equals the square root of a times the square root of b. And that's still true if you're talking about other kinds of roots besides square roots. So for example, well, 100 is equal to 4 times 25. So the square root of 100 is equal to the square root of 4 times the square root of 25. We can check that out because the square root of 100 would be 10. Square root of 4 would be 2, square root of 25 would be 5, 2 times 5 is equal to 10. So here are some examples where we can use that rule. The square root of 49x squared is equal to the square root of 49 times the square root of x squared. And we know that the square root of 49 is 7, and the square root of x squared is, well, we can just write x if we know that x is going to be positive, or if we want to be really careful and allow for the possibility that x might have started out negative, we should write 7 times the absolute value of x. What about the square root of 64y to the 12th? Well, that breaks down into the square root of 64 times the square root of y to the 12th power. So the square root of 64 is 8, square root of y to the 12 is y to the 6th, and so we write 8y to the 6th. What about the cube root of 64x to the ninth? Well, that breaks up into the cube root of 64 times the cube root of x to the ninth. Cube root of 64 is 4. The cube root of x to the ninth is x to the third, so we get 4 times x to the third power. The cube root of negative 1000 a to the sixth b to the third power is, we got the cube root of negative 1000, which is negative 10, times the cube root of a to the sixth, which is a to the 2, times the cube root of b to the 3, which is just b. So our answer is negative 10a squared b. And then the quotient rule for radicals says that the square root of a over b equals the square root of a over the square root of b. And the same rule still applies to other kinds of roots besides square roots. So it applies to cube roots, fourth roots, and so on. So for example, the square root of 9/64, we can break it up into the square root of 9 over the square root of 64. The square root of 9 would be 3, the square root of 64 would be 8, so we get 3 over 8, 3/8. What's the square root of 9c to the 8th over 100? Well, we can break it up into the square root of 9, which is 3, times the square root of c to the 8 power, which is c to the 4 power, over the square root of 100, which is 10. Now some examples of a square root function. F of x equals the square root of 5x plus 9. So this is a function that takes whatever number you put in place of x and gives you 5 times that number plus 9, and then it takes the square root of that for the final result. So if we plug in 0, f of 0 would be the square root of 5 times 0 plus 9. So first of all, 5 times 0 would be 0. 0 plus 9 would be 9, and then the square root of 9 is 3. What about f of 8? If we plug 8 in for x, we get the square root of 5 times 8 plus 9. So 5 times 8 is 40. 40 plus 9 is 49. And then the square root of 49 is 7. And how about f of 4? Plug in 4 for x, and we get the square root of 5 times 4 plus 9. 5 times 4 is 20. 20 plus 9 is 29. And the square root of 29, well, 29 is not a perfect square. So we can't write down exactly what the square root of 29 is, other than just leaving it as the square root of 29. So if we want an exact answer, we have to just write it as the square root of 29. If we want a decimal approximation, you can ask your calculator what the square root of 29 is, and it'll give you something that's approximately 5.385.